Hey guys, have you ever looked up at the sky and wondered, why is it blue? Well, today we're going to dive into that question and find out the science behind it. It's pretty fascinating, so stick around. All right, let's start with some basics. The light we get from the sun looks white, right? But in reality, it's made up of all the colors of the rainbow mixed together. You know, like when you see a rainbow after it rains, that's the sunlight getting split into its different colors. When sunlight reaches Earth's atmosphere, it doesn't come straight down to us. It hits all the tiny molecules in the air, things like oxygen and nitrogen. These molecules are super small, way smaller than the wavelength of visible light. Now here's where it gets interesting. When light hits these tiny molecules, it gets scattered in all directions. But not all colors of light scatter equally. Blue light, which has a shorter wavelength, gets scattered much more than red light, which has a longer wavelength. Imagine you're throwing pebbles into a pond. If you throw a small pebble, like blue light, it makes lots of ripples. But if you throw a big stone, like red light, the ripples are fewer and spread out differently. That's kind of what happens with light in our atmosphere. Because blue light is scattered in all directions, no matter where you look, some of that scattered blue light reaches your eyes. That's why the sky looks blue most of the time. Cool, right? Now, you might be thinking, what about sunrise and sunset? Why is the sky sometimes red or orange? Excellent question. During sunrise and sunset, the sun is lower in the sky, and its light has to pass through a lot more atmosphere to reach us. The blue light gets scattered out way before it gets to our eyes, leaving the reds and oranges, the longer wavelengths, to dominate the sky. That's why you get those beautiful fiery colors at those times. Let's talk a bit about how scientists figured all this out. The person most credited with explaining why the sky is blue is Lord Rayleigh. In the 19th century, he studied how light scatters and discovered that the amount of scattering is inversely proportional to the fourth power of the wavelength. This means that shorter wavelengths, like blue, scatter much more than longer wavelengths, like red. This is now known as Rayleigh scattering. Here's another fun fact. If our atmosphere were made up of larger particles, like the ones in fog or mist, the sky wouldn't look blue at all. It would look white, because larger particles scatter all wavelengths of light equally. This is why clouds, which contain larger water droplets, appear white or gray rather than blue. And did you know that other planets can have different colored skies? On Mars, for instance, the sky often looks pink or butterscotch because of the red dust in its atmosphere. Imagine seeing a sunset on Mars. Now that we're on the topic of other planets, it's interesting to note that the color of the sky can depend on the gases present in the atmosphere. For example, the atmospheres of Neptune and Uranus are full of methane gas, which absorbs red and yellow light and scatters more blue and green light. That's why these planets appear blue and green. Another cool thing about Earth's sky is that when you look from high altitudes, the sky appears darker. This is because at higher altitudes, there are fewer air molecules to scatter the light. That's why astronauts see a black sky when they look at Earth from space. And one more thing, have you ever noticed that the water in seas and oceans also looks blue? The reason is quite similar to why the sky is blue. Sunlight enters the water, and blue light is scattered more than other colors and reflects back to our eyes. Of course, the depth of the water and the materials in it also play a role, but the main reason is the same. Let's add a bit of history to our understanding. Ancient civilizations had various theories about the color of the sky. The Greeks, for instance, thought the sky was blue because of the reflection of the ocean. It wasn't until much later that scientists began to understand the true nature of light and scattering. Also, did you know that some animals see the sky differently? Many insects, for example, can see ultraviolet light, which humans cannot. To them, the sky might appear quite different, possibly with more vivid patterns and colors. Birds, too, have a different perception of color compared to humans. Their ability to see a wider spectrum of light helps them navigate and find food. Let's dive a little deeper into the science. When we talk about light scattering, there are actually two main types: Rayleigh scattering, which we've already discussed, and Mie scattering. Mie scattering occurs when the particles causing the scattering are about the same size as the wavelength of light. This type of scattering doesn't favor shorter wavelengths over longer ones, which is why clouds appear white. The water droplets in clouds are much larger than the gas molecules in the atmosphere, leading to this different scattering effect. Speaking of the sky and its colors, let's not forget about phenomena like the aurora borealis or northern lights. This stunning light display happens when charged particles from the sun interact with Earth's magnetic field and atmosphere. The collisions between these particles and gases in the atmosphere cause the beautiful greens, pinks and reds that light up the polar skies. Also, you might wonder why the sky doesn't look violet, even though violet light is scattered even more than blue. The answer lies in the way our eyes perceive color. Human eyes are more sensitive to blue light than to violet light, and also some of the violet light is absorbed by the upper atmosphere, making the sky predominantly blue. Another interesting point is how pollution affects the color of the sky. When there are more particles in the air, such as from smog or forest fires, the sky can take on different hues. These particles can cause more scattering of red and yellow light, leading to more vivid sunrises and sunsets, or even a grayish tint during the day. So next time you look up at the beautiful blue sky, remember that it's all because of the way our atmosphere scatters sunlight. It's a neat little trick of nature that gives us those gorgeous blue skies by day and stunning sunsets and sunrises. I hope you guys enjoyed learning about this as much as I enjoyed sharing it with you. If you're into this kind of video, we've got another one about why blue is such a rare color in nature. Ever wondered why there aren't any blue animals? Well, I've got a link to that video in the description for you. And by the way, that video is on our team's second channel where we post similar content that doesn't go up here. So I highly recommend subscribing to that channel too, so you don't miss out on any of our team's awesome videos. If you enjoyed this video, make sure to hit that like button if you haven't already. And don't forget to subscribe to my channel because there's a lot more cool stuff coming your way. If there's a topic you'd like me to cover, I'd love to read your suggestions in the comments. Thanks so much for sticking around till the end of the video. Stay curious and full of energy until the next one.